As we talked a little bit earlier, use of paper and map and compass can be utilized to perform triangulation. This is where you look where you are on the map and have the map correctly oriented. And then when you locate the direction of the transmitter, or what you think is the direction of the transmitter, then you make a line from your location on the map to the where you think the transmitter is located. And by taking a number of different position fixes, if you will, and marking them on the map, where all the lines cross is close to the transmitter. And the near transmitter sensing techniques are a little bit more complicated. People have various devices for this purpose. I like, as I said, the body block method the best because it seems to work very effectively for near-in transmitters, but other people have various degrees of attenuation to their antennas that you can use as well to determine where the transmitter is actually located. And the attenuators are very important in that particular technique, and even in the body block when you think about it, because instead of using an electrical attenuator, you're using your body as the attenuator. And as I mentioned earlier, it's useful for finding transmitters when you get really close. And the best part is that the attenuators can be used to determine the true direction of the transmitter as opposed to a reflection. Reflections are signals from the transmitter that are bounced off of other things like buildings or hills or water towers, what have you, and you may get false readings. But with an attenuator, you can tell which signal is the right one because the reflected signals will be significantly weaker, meaning that when you try to get a direction from those, they'll disappear after you put the attenuator on. Okay, I'm going to talk a little bit about the competitive type of fox hunting that is quite popular, particularly in Europe, but it's being practiced all over the world with various radio society. There's several kinds of transmitters. As I said, they can be on 80 meters, which was originally very popular, 80 meter AM with tone modulation. And then, of course, the type we use, which is 2 meters FM. And in the real competitive world, you'll have 4 or 5 or even 6 different transmitters on the same frequency. And they transmit in order: first minute transmitter number 1, second minute transmitter number 2, third minute transmitter number 3, etc. So the goal is to get fixes for each transmitter when it transmits, and use those fixes that you get to map each one. So it's a pretty complicated business if you're doing this competitively. And most of the competitive races, if you wish to call them that, because they are timed, in direction finding are on foot. And people who do that sort of direction finding have to be fairly physically fit, obviously. And the judges, shall we say, of these contests are situated near each of the hidden transmitters because they don't want someone to discover where it is and disable it, which would make it a little difficult for the oncoming people. And so in order to verify that someone has actually gotten close enough to it, not got to the exact location, but has gotten close enough, is they have paper punches hanging from a string on a nearby tree or other place. And you take your card, which has a little block for each of the transmitters, and then you knock a hole in it. And you can't just knock a hole in all 6 of the slots because each punch is different. And again, don't take the punch, the judges are watching. And okay, let's go to the next one. Now let's talk a little bit about tricks of I call it nasty fox. For the people who are really very, very skilled with this, there's a number of challenges that you could create in order to make it a little more difficult. One of the challenges is to take, instead of an omnidirectional antenna, which is what we normally use, and take a beam and point it, say, toward a mountain or an office building. And of course, that will give you a pretty strong reflection, and it could mislead you if you don't utilize your wits about you and take multiple readings at different locations. Another way of making it more difficult is to put the hidden transmitter on a platform, like almost like a record player, and rotate it and have a directional antenna connected. So all of a sudden you have signals coming from all different directions. Another way of using tricks is to use varying power levels. And indeed, the hidden transmitter that I will show you has a feature where you can transmit either at 5 watts or 800 milliwatts. And for people who use signal strength, this could obviously throw them off, because one transmission's at 800 milliwatts and one's at 5, you get very confused. And the Doppler system that I spoke about earlier, where you're listening for a drop in 1,000 hertz tone amplitude in your receiver, some of the hidden transmitters could transmit 1,000 hertz tone, which would render the Doppler technology worthless. And the last thing, most difficult way of frustrating people, shall we say, is short transmitting intervals. Some really expert groups out in California will transmit for 1 minute and won't transmit again for an hour. That's, if you didn't get your fix in pretty quick, then you'd be waiting an hour to get the next one. Okay, in summary, before we start the show and tell, direction finding can be fun, obviously, but it can save lives in the case of finding locator beacons, some crashed airplanes or other sources. And of course, we can find jammers to our repeater by DFing them on the input, not the output of the repeater. All right, I have a few little things to show. I didn't bring any directional antennas with me because I did not have room to bring them, but I did bring a couple of FOX-Hunt transmitters, including the one that was used on the most recent FOX-Hunt, which was held, I believe, in October of 2019. So let me get those now. Just go over there. No, really. Okay, so this is what the box for the what I'll call high-powered hidden transmitter looks like. And I want to show you what it looks like on the top, because when you're hiding this thing, you really have to be concerned that someone finding it will think it's something that is dangerous, and therefore you have to provide information like this. Otherwise, when you find the hidden transmitter, you may also find the police waiting for you. Okay, so this is the way I identify the hidden transmitter, because this way, at least if they have concerns, they can call my cell phone. Okay, this is a quarter wave 2-meter antenna. It's roughly 19 inches. Let me show you what the inside of the box looks like. It's nothing fancy. Let me take this off. Okay, the inside of the box, I'll take the pieces out because I think it would be much easier to look at if I have the pieces out as opposed to have them in the box. This is the battery. It's not a nice lithium battery, but it's a regular lead acid type battery. And this will run the hidden transmitter for days, because the hidden transmitter, as I said, is only 800 milliwatts. Okay. Now this is the hidden transmitter. Disconnect some things here. Now, there are more sophisticated hidden transmitters than this one. But this one is based on a kit that used to be sold by Ramsey Electronics back in the 90s. Okay. Now, this is the output transistor here with the heat sink. And this is the PIC chip, which contains the commands for the microcontroller. Okay. And this, you probably asked, what is this? This is the backup battery that allows the memory of the PIC chip to be retained. Now, in order to program this, you need two things. One is you need a speaker when you're programming it, because you want to hear what you're sending during the programming. You need a key and you need an on-off switch. So let me set this up and show you what it sounds like on a 2-meter receiver. So who's got a handheld? Okay, 146.565 is the frequency. And we'll take this and reassemble everything, and then we'll go ahead and start. Okay, so this is the antenna, and this is actually a fairly sophisticated transmitter for a hidden. I'll assemble it differently to take it home, but this will accomplish the goal. So the transmitter's inside the box, and our power supply is conveniently right here, 12 volts. And let's go ahead and you on 565?
146.465.
146.565. Okay, so we're transmitting now. Now you should be hearing it.
There's no PL now.
Okay, it is transmitting. How I know is that the receiver is quiet. The squelch is open, but it's quiet. So the signal is there. And in about a minute or so, you will hear the ID, which is my call sign, N4DR. Obviously, we need to have identification anytime we do transmitting. So okay, so that is a legal requirement, and I'd have it set to identify every 1 minute. And the period between when it identifies, you got dead carrier, which is good if you know what you're looking for. So basically, when you're aiming your antenna, your Yagi, say, and your attenuator, you would want to aim for the best quieting, okay, because that would indicate where the signal was the strongest. If you're using the body block method, you would want to turn to where the noise was was the least. I'm sorry, let me start again. Where the noise is the greatest, because that is the direction towards where the greatest attenuation is. And a lot of people don't understand this, that those two concepts are very different. So if you're using an attenuator versus using a body block method, you have to understand the difference. So basically, that's what we use for most of our hunts. Now I have another hidden transmitter. This one's real easy to show. The Altoids 10 hidden transmitter. And I'm going to shut off our orange friend here. Put this fellow on instead. Now this is what is a real tiny hidden transmitter. Notice the size of the board. In the Altoids tin case, and there's obviously plenty of room and a clip for the battery. So let me put the battery in. And this particular circuit board is produced by WB6 Echo Yankee Victor in California. Okay. This is what it looks like with the battery in place. Now the unit needs an antenna. So to transmit our mighty 10 milliwatts, we have a dipole antenna. So we're going to put our dipole into our antenna jack, close it up, and we turn it on. Now, remember, this guy's not turned on. Okay. Oh, battery's loose. Okay, so this is the ultimate hidden transmitter because you can really hide this thing. So now, unlike the other transmitter, this comes pre-programmed. So it's programmed such that your call sign is pre-programmed on the chip when you get the unit. So you have to tell them what you want on there. Put N4DR/FOX. And so that's there. This one's a little bit different. It identifies repeatedly over a minute and then shuts down for another minute. The reason is the board is so small, if you ran it continuously like this one, it would heat everything up and eventually self-destruct, even at 50 milliwatts. Why is this fellow not behaving himself? All right, let's do it. Okay. Well, every good talk has some technical flaws, so I guess this will be our technical flaw for tonight. All right, well, you understand the concept, and that's the important thing. And so these are two options. In fact, I have found that when doing beginning type fox hunts, it's probably better to use the weaker transmitter. And people used to say, well, you know, at the starting point, everybody should be able to hear it, this sort of thing. But what happens when you do that is that everyone starts at the same place. Everybody gets the same reading. They all get in the same direction. Well, so what I recommend is that people start at different places. That way you get your bearing and you base your direction that you're traveling in based on the bearings that you personally make, not what somebody else in your group makes, etc. So that's about all I have. And I'm going to ask if there's any questions for folks out there or folks here in this room. Okay.
This is David.
So
I have a comment. Can you hear me?
Oh, Dave has a question.
Yeah, this
Go
is not
ahead,
a
Dave.
question, but this is
I can't
a
hear you very well. You need to move the speaker.
testing 1 2 3 3 2 1.
Now I got it. I hear you now, Dave.
Okay. This is a comment from the late Bob Bruninga, WB4APR. He said, triangulation is good, but people overlook a very basic method. Look, cross out on the map where the transmitter you think is not. You know, so you turn around with the body block method, and you can actually just take a pencil and just roughly sketch out, cross out, hatch out where you think the transmitter is not, and what's left is what you focus on instead of running around the whole map. You know, I thought that was very interesting. But that's Bob for you. You know, always had interesting ideas.
Yes.
That's all. Anyway, back to the meeting.
Yeah, personally, WB4APR is a silent key. He passed on, I think, about a year ago. And he was absolutely a genius. He was the one that came up with APRS, and a very brilliant man. Okay, I'm going to attempt to demonstrate the body block method. I don't know if this is going to work or not. Let me turn since the other one's not working. Okay, so you can. All right. That's not what I wanted. Let's try this again. All right, never mind. I'll try and demonstrate the technique without the use of the transmitter. Something happened to the PIC chip, so we need to reboot it. But okay. Now, when you get close to the hidden transmitter, you and don't have any other equipment other than the handheld and the antenna, one of the best ways of getting attenuation is to remove. So what you do, obviously you have the receiver on the appropriate frequency, and you can put it behind you like this, and then slowly turn until you hear what? The greatest degree of noise, not the strongest signal. Why? Because you want to be pointed at the point where the greatest attenuation is, which is straight ahead. Okay. This is in contradistinction to using a Yagi with your handheld and a signal meter on the handheld. In that case, for 2 meters FM, you're looking for the best quiet. In other words, you want to have the strongest signal, and the strongest signal will be in the direction of the best quieting. So it's 2 different techniques, but the body block works very good, especially if you remove the antenna. There's one further step in attenuation that you can do, and that is dial the frequency off by 5 or even 10 kilohertz and use the same body block method. And that's a tremendous amount of attenuation. So you should be able to get an even better idea of the direction of the transmitter, because you've now got 20 or 30 dB of attenuation, which you've added by tuning off the frequency. All right, I carried on a little bit longer than I intended. Thank you all very much, and hope you learned something.
Yay.
Question, Mark?
Oh,
So
yes.
I think you left out an important detail. You turn off the squelch, so you get the noise.
Oh, right. Yeah, that's you're very correct, David. Yeah, you have to have the squelch open and clear. So yeah, you do need to have the squelch open, as Dave says, in order to hear the noise. So and you can do that. Well, there's a couple ways you can do it. Obviously, with many handhelds, they have a squelch control, so you can just open it that way. Or in ones that don't have a squelch control, you can set the squelch down to 0, and that's essentially an open squelch.
Is the Doppler antenna a circular antenna?
No, actually, it's not. The Doppler antenna has 2 components. It's almost like a dipole, but it's not a dipole. The way Doppler works